Hey everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we will work on longest increasing subsequence. So, today's problem is one of the most important dynamic programming problems. If you understand this problem properly, you will unlock the real power of DP patterns. First, we will solve it using recursion and then DP. So the problem states that we are given an integer array nums and we need to return the length of longest strictly increasing subsequence. For example, if you consider this input, the longest increasing subsequence would be 2, 3. It is subsequence, so it could be any random number but in the given order 2, 3, 7 and 101. If you choose any other numbers, they will be in the decreasing order, so the length of this is 4. That is why the answer is 4. So let's write the code for using recursion first. At every index we will have two choices, either we pick the element or we will not pick the element. Let me return the helper class, maybe solve, and I'll be passing the input array and I'll pass the current index and previous index for now -1. Let's implement this. The return type would be solve, giving the length, and we passed nums index and previous index. Now, so the base condition would be if we reach the end, then we can return 0. So if index is equals to nums dot length, then we will return 0. And then now we have two options, either we will pick it or we will not pick it. In case if you do not pick, then we will call the solve method passing nums and the next number because we did not pick it and the previous index. In case if you pick it, initially let's take it as 0. So before calculating the pick, we will check if the previous index is equals to -1, which means that is invalid. If it is -1 or if the current element nums of index is greater than nums of previous index, then it is not in a increasing order, so we should not consider this. So if it is greater, then we will update pick with current number plus solve of index +1, and the previous index would be the current index. Because the previous index is -1, then that is invalid. We will pass current index in place of previous index, and then at the end we will return the maximum of these two because we need the maximum possible length of pick and not pick. Let's run the code. Oh, we didn't pass the array. Okay, it is working. So since at every step we have two options, either we pick or we don't pick, so the time complexity would be O of 2 power n, which is very slow due to overlapping subproblems. Now we need to convert this into dp to reduce this problem. So yeah, for DP we obviously need a DP array, but we need a 2D DP array. I'll let you know why. The length would be num's length and num's length plus 1. So now let's initialize everything with -1. So let's take a for loop I equals to 0, I less than nums dot length I plus plus, and for j0, j less than or equals to nums dot length j plus plus. Let's update dp of I of j to -1. Now we will return a new method solve, passing the input nums, current index, previous index, and dp. Now let's implement this solve method. The return type would be int, giving the maximum length, and yeah, the base conditions would be same. If index is equals to nums dot length, then we will return 0. Oh wait, we need to pass the input nums and index and previous index and dp. Okay, now we will check if the current value in dp is not equals to -1. If it is, then it is already calculated, then we will straight away return that dp of index and previous index plus 1. If this is not equals to -1, then it means it is already calculated, because we have initialized it with -1. If it is not -1, that means we have already calculated it. So we will return dp of index and previous index plus 1. Okay, now again we have two options. Either we pick it or we will not pick it. In case if you do not pick it, then we will pass this solve of nums index 1 previous index, and we are also passing dp. And for pick, let me copy this. Okay, for we have initialized pick with 0 and if previous index is -1 or nums of index current index is greater than previous index, then we will update pick with 1 plus solve of nums index plus 1 current index, and we will pass dp2. At the end we will return, but before returning we need to update it. So before returning, let's update this with dp of index and previous index plus 1 equals to this. Okay, let's run the code. I've just copy pasted the same code, just that we are saving it and checking if it is already calculated to avoid recalculations. Let's submit it. So yeah, it is accepted. Since we have used two for loops here end to end, the time complexity would be O of n, and the space complexity would also be O of n, because we are using a 2D array, which is much better than 2 power n. So, yeah, that is it for today's problem, and I will see you in the next one.